Today we're going to look at expanding binomials. Binomial meaning two terms, and what happens when we have an exponent on those two terms. So the first one, pretty easy. Well, anything to the 0 power, we all should know, that's just going to give us 1. And I'm going to write this way out here, and there's a reason for that. Here a little bit. That's just 1. Okay. Next one, a plus b to the 1. Well, anything to the 1 power is itself, so that is just a plus b. Now, a plus b squared. If you're having trouble remembering that one, let's come off to the side and multiply it out. So I'm going to come down here and look at a plus b squared. Now remember, that means a plus b times a plus b. If you like using the multiplication box, which I do, you can use that to multiply. That's a and b, a plus b, and plus b. A times a is a squared, a times b is ab, a times b is ab, and that's b squared. This is a pattern you would do well to memorize throughout Algebra 2. That's a squared. We have two of these. 2ab plus b squared. That pattern needs to be memorized. Alright, so I'm going to fill in my little chart here. That's going to be a squared plus 2ab plus b squared. Alright, next one, a plus b cubed. So I'm going to come back down here for where I'm doing my work. A plus b cubed. Now that means I'm going to have a plus b times a plus b times a plus b. Well, what's really nice about doing this way is that, hey gosh, didn't I just figure that part out? That is right here. That's a plus b squared. So I need to take that times another a plus b. So on the side I've got a plus b times a plus b squared, which was a squared plus 2ab plus b squared. Now I'll try to go through it kind of slowly, but I want you to make sure we can do our rules of exponents and everything very well when we're doing these. A times a squared. A times a times a, that's a cubed. A times 2ab. Well, the a times the a gives me a squared. I like keeping the coefficient in front and our variables in numerical order. A times b squared is ab squared. B times a squared. You could write it ba squared, but mathematicians, we're crazy. We like them in alphabetical order. A squared b. B times 2ab. Well, the b times the b is b squared, so that gives me 2ab squared. B times b squared is b cubed. Now, like terms means it has the same variables and same exponents on those variables. So here's an a squared b. These are like terms. This one has a b squared, a b squared. And when you're combining like terms, you're adding your coefficients. Which remember, when it doesn't have anything, that means it's a 1. So let's see what we get when we take this out. We will get a cubed, 2a squared b, and another a squared b. That's 3a squared b. 1ab squared and 2ab squared. That's 3ab squares. And then there's a b cubed. So let's go ahead and bring that up to the top. So our new one, for a plus b cubed, we will get a cubed plus 3a squared b plus 3 AB squared plus B cubed. Next one, A plus B to the fourth. A plus B to the fourth. All right, so this time we've got it 4 times. Now remember, since we just did this up here, that's A plus B 3 to the third power, that is right here. We've already done part of the work. Now all I need to do is times A plus B times what we got the last time. So I would have A plus B, and I don't know if I gave myself enough room, so I'll have to go all the way to the edge of the page. And our answer from last time was A cubed plus 3A squared B plus 3AB squared plus B cubed. And now all we need to do is multiply. A times A cubed, A to the fourth. A times 3A squared B, that gives me 3A cubed B. A times 3AB squared gives me 3A squared B squared. A times B cubed gives me A B cubed. Now, B times A cubed is going to give me A cubed B. B times 3A squared B gives me 3A squared B squared. B times 3AB squared gives me 3AB cubed. B times B cubed gives me B to the fourth. Like terms, beautifully enough, end up being in my diagonals. So let's see what we get. There's an A to the fourth. 3 of these plus another one, that gives me 4A cubed B. That's 6A squared B squared. 4 plus 4AB cubed plus B to the fourth. Now I almost ran out of room. Let's go ahead and write this one down up in our chart at the top. All right. This was A to the fourth plus 4A cubed B plus 6A squared B squared plus 4AB cubed plus B to the fourth. I want you to look at this for a second. Does it look like we have a pattern starting? I want you to look at the coefficients. Let's just start with the coefficients. My coefficients, if I look at the very top row, I have a 1, right? The next one, the coefficients, 1 and 1. The next row, 1, 2, 1. The next row, 1, 3, 3, 1. The next row, 1, 4, 6, 4, 1. Are you seeing a pattern? I hope you are, because this is called Pascal's triangle. If you'll notice, look at the ones directly above. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So what do you think the next row would be for coefficients? They always start off with a 1. 1 plus 4 would give me 5. 4 plus 6 would give me 10. 6 plus 4 would give me 10. So give me a 5 and a 1. How neat! We have our coefficients. So I would know that I would have a 5 here. I don't really need to write the 1. I know I'd have a 10 here. 10 here. Oops, I ran out of room. Should have wrote it in the row above it. 5. And then there would be a 1 on the last one. Sorry about that. I kind of wrote it in the wrong way. But let's see if we can figure out what's happening with the exponents. A to the 4th, a cubed, a squared, a. Well, I bet this one's going to have a to the 5th by itself, because that matches this pattern, a squared, a cubed. Then this next one would have to be a to the 4th. And this next one would have to be a cubed. The next one would be a squared. And the next one would be a. And the next one wouldn't have an a at all. The next one in the pattern, see, this one doesn't have any b's. This one has b. Next one has b squared. The next one has b cubed. The next one has b to the 4th. And this one we end with b to the 5th, which matches our pattern this way. That would be my answer for a plus b to the 5th. Nifty. Pascal's triangle can be used to expand binomials. Now I want to see what happens if I change it to a difference instead of a sum. So let's see how far we really have to go with this. Let's look at a minus b squared. What would happen there? Well, that's a squared minus 2ab plus b squared. I already know that one. What about a minus b cubed? Now remember from before, that's going to end up being a minus b times what we had before. So a minus b times a squared minus 2ab plus b squared. A times a squared is a cubed. A times negative 2ab is negative 2a squared b. A times b squared is going to be ab squared. Negative b times a squared, negative a squared b. Negative b times negative 2ab, going to be a positive, 2ab squared. Negative b times b squared is going to give me a negative b cubed. Looks like my diagonals this time, this one's negative and this one's positive. So I've got a cubed minus 3a squared b plus 3ab squared minus b cubed. So it's kind of alternating. The other thing I want you to notice is the exponents on the b. The b was the negative one, right? The exponent here for b would be 1. Here it's 3. So every time it's an odd exponent on b, you get a negative. You can also just think about it as the fact that it's just alternating, and that's fine by me as well. Now, how could we use these to really do a problem? Now I'm going to go ahead and draw the triangle again so we can refer back to it. We had 1, 1, 1, 1, add those together, we get 2, 1, 1, add, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, Okay, I kind of got stopped in the middle of taping stuff. You have a little glitch there. I finished filling in the Pascal's triangle all the way up to the 7th row. That would be for anything A plus B to the 7th. Let's see if we can remember how to use that for the 6th, which would be that row right there. So the first one, the coefficient is going to be 1, A to the 6th, because we start with that one. So these are the coefficients, and since it's plus, it's going to be plus in between each one. Next coefficient is going to be 6. Now, the A comes down 1, and we're going to start putting in the B's, and they go up as we go. Next coefficient is 15. The A's come down 1, the B's go up. Next one is 20. A's come down 1, B's go up. The next one is 15. A's come down 1, B's go up. Next one is 6. A's go down 1, B's go up. Oops, go up. That would be a 5. And the next one is a 1, which I don't need to really write. A's come down 1, they basically disappear, and we got B to the 6th. Now let's practice doing one with a negative, or minus in here. So A minus B to the 7th. So we're going to use this last row. Now, when it's subtraction, we're going to alternate negatives. So we'd start with A to the 7th, and then the first one is going to actually get subtracted. Here are my coefficients. We start with 7. The A's go down 1, the B's go up. Now we have addition. A's go down 1, B's go up. Subtraction. A's go down 1, B's go up. I want you to also notice something. We're on the 7th level. If you add the exponents, 6 and 1, 5 and 2, 4 and 3, they'll always add up to 7. Okay, we did subtraction. The next one's going to be addition. A's go down 1, B's go up. Minus 21. A's go down 1, B's go up. Plus 7. A's go down 1, B's go up. Minus 1, B to the 7th. Pretty nifty, because that saves you a whole lot of time. All right. Now, what about if it's not just A and B? What if we have other things in there? Like here, 2x plus 3y to the 4th. Well, the pattern is still going to be the same. So let's look at what it had been for A plus B to the 4th. Well, A plus B to the 4th, that's 1, 4, 6, 4, and 1. So that's A to the 4th plus 4, A cubed B plus 6, A squared B squared plus 4, AB cubed plus B to the 4th. That's the pattern. The pattern holds true. Now, instead of having an A, we have 2x. So it needs to replace all of the A's. So here is A to the 4th. And we'd have plus 4 A to the 3rd. Now, what about B? What about B? B is 3y. So I place B with 3y. Now, I've got plus 6. Next part is going to be A squared, and A is being represented by 2x. B is 3y. And we have plus 4. A is 2x. B is 3y. Oh, and the last one is just going to be 3y to the 4th. So I'm going to go ahead and work this one out with you, just to kind of review our rules of exponents and everything as well. 2x to the 4th, that means I have 2x times 2x times 2x times 2x 2 to the 4th is 16. Then I have x to the 4th. Plus, now let's just go ahead and break this down and look at each piece. 2x cubed would give me 8x cubed, because 2 cubed is 8. Let's go ahead and do all of the exponents. 2x squared. 2 squared is 4, and then we have x squared. 3 squared is 9, and then we have y squared. 2x. 3 cubed is 27. 3 to the 4th. Well, 3 times 3 is 9. 9 times 9 is 81. Y to the 4th. Now, I just need to do a little bit of arithmetic, and we are done. We have 16 x to the 4th plus 96 x cubed y plus 216, and I have an x squared, y squared. 8 times 27. I ended up with a 216 again, x, y cubed, plus 81, y to the 4th.